Everyone says hydrogen is the fuel of the future. Clean, green, and full of promise. But what if it isn't as harmless as we think? Hi everyone, I'm Anna. Welcome to my channel where we learn English through curiosity and discovery. Today we'll explore a fascinating article from New Scientist called "Is Hydrogen a Climate Problem?" You'll learn real environmental vocabulary, discover the science behind hydrogen's hidden warming effect, and improve your English. Let's dive in! For those of you who are worried about the science part of the class, let me explain a bit. Hydrogen is the lightest and most common element in the universe. It's everywhere. In water, plants, and even our bodies. When we use hydrogen as a fuel, it doesn't produce carbon dioxide, only water. That's why it's often called a clean energy source. Scientists believe hydrogen could power cars, factories, and even airplanes without adding greenhouse gases to the atmosphere. But as today's article shows, hydrogen might not be completely harmless. Even though it looks clean, it can still have indirect effects on the climate. And that's what we are going to explore. The article is pretty long, but I have chosen the most interesting and useful key information. On the left side of the screen, there will be the text, which I will read and explain in simpler words. However, on the right side of the screen, you will be able to see key vocabulary with definitions. So feel free to stop the video and read those. Alright, let's get started. Before we start reading, let's learn some key words. And the first one is, of course, atmospheric hydrogen. It's hydrogen gas that exists naturally in the air. A greenhouse gas. It's a term that we use to describe a gas that traps heat in the atmosphere, like carbon dioxide or methane. A byproduct. It's something that is made as a side effect. So it was unintentional. We did not want to mix this thing. Alright, now we are getting a little bit more scientific. So bear with me. Hydroxyl radicals. Those are tiny molecules that clean the air by removing methane, which, if you remember, is one of our greenhouse gases. So let's start reading. Levels of hydrogen in the atmosphere have jumped by 60% since pre-industrial times, underscoring the dramatic impact fossil fuel burning has had on the planet's atmospheric composition. Wow, 60%! That's a huge increase. It means that since humans started burning coal and oil, those are fossil fuels, there's much more hydrogen in the air. The phrase underscoring the dramatic impact means that it clearly shows how serious this change is. So this increase in hydrogen is a big deal. Although hydrogen isn't a greenhouse gas, it has an indirect warming effect through reactions with other molecules. This sentence is the key to the whole article. Hydrogen doesn't trap heat directly, so it isn't really a greenhouse gas, but it reacts with other chemicals in the atmosphere and changes how long those gases stay there. It's an indirect warming effect, like a hidden chain reaction. The findings come from the first ever long-term record of atmospheric hydrogen, compiled using data from ice cores extracted in Greenland in 2024. So this is a huge scientific breakthrough. Scientists in Greenland took deep ice cores, which are basically frozen layers of ancient air, and used them to see how hydrogen has changed over hundreds of years. Each layer of ice contains tiny bubbles of ancient air, which scientists can study to learn what Earth's atmosphere was like hundreds or even thousands of years ago. But why do we consider this to be such a big deal, such a big breakthrough? Let's find out. Hydrogen is a small, lightweight molecule that escapes easily into the atmosphere. That means hydrogen has usually leaked from ice cores before samples make it back to laboratories, which are often thousands of kilometers away, making it very difficult to compile a long-term time series of its atmospheric levels. So hydrogen is tiny and it leaks out quickly. That's why until now scientists couldn't build a long-term record. The hydrogen kept escaping, kept running away before they could measure it. Hydrogen concentrations have increased from about 280 parts per billion in the early 19th century to about 530 parts per billion today. From 280 to 530, that's almost double. Parts per billion just means how many hydrogen molecules are mixed in the air. This rise confirms that human industry has changed even the tiniest parts of our atmosphere. Can you imagine? Hydrogen is released as a byproduct when fossil fuels or biomass are burned. A byproduct is something that's created as a side effect, as you already know. So it wasn't really an intention. So every time we burn fossil fuels, whether it's coal, oil, or even plant material, otherwise called biomass, hydrogen escapes into the air too. Patterson and his colleagues combined information from the ice core records with modeling to try to build a picture of why hydrogen levels have fluctuated over the last millennium. So interestingly, hydrogen levels have gone up and down naturally over the last 1,000 years. So not all change is caused by humans. Some of it comes from natural climate cycles. Phew! For example, the ice core records reveal hydrogen levels in the atmosphere dipped by 16% during the so-called Little Ice Age, a period of lower temperatures between the 16th and 19th centuries. During the Little Ice Age, which was a colder period between the 1500s and 1800s, hydrogen dropped by 16%. This suggests that when temperatures fall, hydrogen levels also fall. So hydrogen is connected to temperature, and temperature changes it back. That could have worrying implications for the future, suggesting hydrogen levels in the atmosphere could be much more sensitive to climatic changes than we thought, says Patterson. Worrying implications means possible future problems. Here, scientists warn that hydrogen might respond even more strongly to future warming than we expect. In other words, small changes in temperature could cause big reactions in hydrogen levels. When in the atmosphere, hydrogen competes with methane to react with hydroxyl radicals, molecules crucial for removing planet-warming methane molecules from the atmosphere. Okay, this is where it gets scientific, but stay with me. Hydroxyl radicals act like the atmosphere's cleaning team. They remove methane, which is a powerful greenhouse gas. But hydrogen competes for those radicals, meaning there are fewer left to clean methane. Result? Methane stays longer and traps more heat. The more hydrogen there is in the atmosphere, the less hydroxyl there is to react with methane, says Patterson, prolonging the warming effect of methane in the atmosphere. Right now, there is about half a part per million of hydrogen in the atmosphere. Based on our best estimates, that provides something like 2% of the total anthropogenic warming effect. That quote says it perfectly. More hydrogen means fewer hydroxyl radicals, which means more methane left in the air. According to the scientist, hydrogen might already contribute around 2% of all human-caused warming. That may sound small, but in climate science, 2% is quite significant. An understanding of the hydrogen cycle is crucial to judge whether the mass adoption of hydrogen fuel could bring unintended consequences. And this is the final takeaway. Before we switch completely to hydrogen energy, we must understand the hydrogen cycle, how it behaves, changes, and interacts with other gases. Otherwise, a clean solution could create even more problems. Now that you know more about the topic, you can practice speaking and even writing. Answer the questions by either pausing the video and speaking or by sharing your thoughts in the comments. So the first one. Do you think hydrogen should still be used as a clean fuel? 2. What other green technologies might have side effects? 3. Is it better to take risks with new energy sources or stick to what we already know? Oh, and don't forget to check out the description box, because there you will be able to find a full article with my notes and a vocabulary list as well. Toodles! See you soon!